My name is Bob Wagner, and I'm going to take you through an overview of the data center market and how it's being affected by AI. We'll talk a little bit about trends, and then seeing what really is changing with the data center market, or actually the data centers themselves. So if you take a look at the box on the right, you're going to see a lot of things are changing drastically. And when we say AI revolution is here, we mean it. The whole data center market is being flipped upside down. And that's because the requirements for AI are much different than they've ever been. You have between enterprise and hyperscale, and now you have AI. It's even more of what the hyperscalers are doing, and it's also different. We're going to talk about the growth in GPUs. It's from 2023 to 2028. They're going to quadruple. And frankly, that might be a non-aggressive way to look at it. It might be even more than that. That means that the AI GPU servers could be upwards of maybe 50% of all servers going into data centers. That is a tremendous change from just like 2 or 3 years ago when lots of people knew AI was. And so what comes with that change? You're going to find power. And that's going to be probably the biggest thing. Rack right now is around 10 kilowatts. We're talking about well over 100 kilowatts for the latest Nvidia Blackwell systems. That's a 10 or maybe even 12x delta. And that's just over a matter of like 5 years. You're also going to see a lot more cables. When I talk about 4x more fiber cables network, again, I think I'm being, not aggressive at all. It could be much higher than that. You're going to see more cooling liquid needed. In fact, you're going to see more of pretty much everything. So when you think of AI, think of I'm going to need a lot more of everything I'm doing today. And here's that growth chart. Unbelievable. 2019, the GPU market, that's just sales of GPUs, was $6 billion, projected to be $114 billion in just 6 more years from now. If you look at the Nvidia roadmap, and this is just the last several years, every 2 years they come out with a new GPU system, a new server, and as you can see from the far right, the power goes up. Now, when we're looking at 2024, they introduced the Blackwell system, and that's at 1,000 watts per GPU. That's really hot. But at the same time, that is around 15x more compute performance than the Ampere, which came out just 4 years ago. Now, don't be too frightened about the Blackwell at 2,700 watts. The reason that's so high is because there's 2 GPUs and 1 CPU on the same substrate, so it's kind of doubling up. But what's going to come out in 2026 called Rubin, and we don't know a lot about it, it's still pretty early, but we do know that NVIDIA is going to be focusing on trying to reduce the power. But remember, the computational performance is way outstripping the amount the power is going up. Even so, as Justin will talk about a little bit later on, that's going to put a lot of stress on the data center physical atmosphere. All right, so when you're thinking about putting AI in, what do you need to do? First of all, you need to make sure you understand that there's 2 networks. There's the training and the inference. And they're separate networks, and they're different, and they're used differently. So for the training, that's basically collecting all the data sets you want. It's basically teaching the system to learn, collect the information, do some analyzation. But now when you want to use that data to produce new content or predict what's going to happen in the trends, that's where the inferencing comes in. So you could have the training and inferencing portion of your network together in the same building, but they don't have to be. A lot of times you're going to see inferencing out closer to the customer, and training maybe in a data center where it can get the maximum amount of power as cheaply as it possibly can. Not need to be co-located. And here's just an example of the many millions of different ways AI can help you out. It can do predictive, it can do new content. We really won't get into it, but the benefits are real. This is not going to bubble. People are seeing big time savings, and I think this is going to be a growth market for the next decade. What's really interesting is right now, if you look at it, mostly it's the hyperscales the Amazons, Google, they're the early adopters on everything, and they're doing the same thing here with AI. But we know it's going to hit the premise, the enterprise, and it's going to hit the edge, and it's going to be where it needs to be, and everybody will be able to use it. So it's going to be some really, as Barron says, some very exciting times. The growth is unbelievable right now, and Panduit can help you with that growth. So just to kind of recap a little of the data center trends, the power, cooling, and fiber densities are going to grow beyond anything we have today. And in fact, most data centers, even 2 years ago, may not be able to handle AI. And it's mostly because of the power and the liquid cooling that they may need. So expect a lot new data center builds, and expect them to be built in areas that do not necessarily have data centers today. Because again, they're going to be looking for specific needs of the AI system, especially with the power and the cooling. The power consumption is going to be also driving the data centers to become potentially suppliers of their own power. The grid is not going to be able to respond as quickly as needed, and you're going to be seeing a lot of renewable energy. You're going to see wind, you're going to see solar, even nuclear being added on and expressly for the data center. Most large AI is going to be rack and stack, and that means an integrator is going to take a cabinet, load it up with all the compute, switching, the cabling even, and it'll just roll it right into the data center. And that's being done so you can do the installations very, very quickly. Enterprise customers there's going to be large clusters, but enterprise customers are only going to have probably 1 to 2 GPUs per rack, I should say GPU servers per rack. And that's because of the power. If you have more than 2 of these, you really are going to be running out of power, and you're going to have a hell of a time trying to cool that. And you're probably not going to have more than, say, 10 of these servers per building, because frankly, their usage isn't going to be that large. And again, the power is going to be a limiting factor. The direct-to-chip cooling is going to be a must. The Blackwell GPU 200 came out, and it is a must that it is cooled. It also does air cooling as well. A few people, like maybe the supercomputing and cryptocurrency, are looking at immersion cooling, but not that many. So right now, it looks like direct-to-chip cooling is going to be the main way to cool these big AI systems. And fiber is going to be used for all rack to rack. You will still see copper DAC cables used in rack, but outside of that, it's going to be fiber. So to talk a little bit more about the fiber network and architecture, how it's changing, I'm going to go into some slides here that show the enterprise from many years ago was used a 3-tier approach, and then we moved into spine leaf for hyperscalers. And now what does AI need? AI wants all the GPUs to talk together seamlessly, as quickly with low latency as possible, that all those GPUs, even if there's thousands of them, are basically treated as one giant brain. So it's seamless communication, very quick and very agile. Hyperscalers do that to a good effect, but new rail optimization networks that AI is requiring do that even better. And that's with the NVLink switches that basically take those GPUs and let them talk together very quickly. What you'll find is a classic leaf spine architecture, but that leaf spine is going to be a little bit different. You'll see that the speeds will be a little bit lower on AI for now, because InfiniBand has not come out with 800 gig, and that'll be changing very quickly. But for right now, if you're going to use InfiniBand, it'll be at 400 gig. And don't worry, even if your front-end network is using Ethernet, you'll be able to take the InfiniBand and Ethernet and seamlessly put those together, because the industry has made sure that that works out. Most of the clusters will be shorter reach, so they'll use multi-mode. And you can see the data centers themselves, the megawatts, are dramatically larger for an AI system. And this is what I mean when I talked about rail optimization, that top slide. This is an Nvidia H100. Each of those boxes at the bottom are a server. Each server has 8 GPUs. Each GPU attaches to just one leaf. There's no oversubscription. But as you can see, when you go to leaf up to the spine, you get that classic meshing. But what's different here is the MPO cables. You're not taking 2 fibers out of many MPO cables and distributing it. All 8 fibers from every MPO goes from leaf to spine to GPU. So it's a little bit different in the spine leaf. Otherwise, it's very similar once you get out to leaf and spine. This is what a SuperPod DGX B200 Nvidia looks like. You'll have 16 server racks, 2 network racks for a total of 18. You'll notice that each of these racks, those brown boxes, those are the servers with 8 GPUs each. They only have 2 per rack because they're trying to keep this to an air-cooled level. If you can add more and go to liquid cooling, you can do that. But this is the simpler system, easier for most people to adopt, because putting liquid cooling into a new data center is easy. Putting it into an existing data center, not so easy. These pods take up 500, or they need 508 MPO-8 cables. So you can see as you add pods, the fiber goes crazy. You have a lot of it. And this represents exactly how that'll look. The bottom are the servers, the middle row are the leaf switches, and then the top of the spine switches. And that beautiful geometric pattern shows you just all that fiber cabling, and you can imagine that's hard to install. A physical representation of what those switches look like is this. So this is where Panduit can really help. We're cable management experts. We've got some great systems, and that is, all that fiber is going to be a problem. This is what you can do with cable management, the pictures on the right. It gives you better airflow. It gives you better ability to fix things if they're broken, make changes. It protects the circuits. It has proper bend radius. Panduit is there to help you as you migrate into AI solutions with good cable management. And RapidID, free with all of our fiber cables. We have unique barcode labels on that. You can get a barcode reader wherever. You download our free software. You scan all those barcodes. It immediately gives you on your system exactly where each cable is going to, or is coming from and going to. And it's a seamless way to quickly know exactly where all your cables are. And it's free. Another way that Panduit can help is we have the very best multi-mode cable on the market. It's called SignatureCore. We developed it 15 years ago, and it's still by far the best multi-mode cable out there. It gives you the longest reach. If you take a look on the right side, you have the 4 different parameters, or 3 different parameters, and each one of those, the black line represents SignatureCore, the green line is OHM5, and the red line is OHM4. So you can see the performance advantages by using SignatureCore. And when you're going to be putting racks in, they're going to cost $500,000 to maybe even $1 million each. I think using the very best cable and components you can get is very, very important. Now I'm going to turn it over for Justin to talk about AI and rack power.
Thanks, Bob, for the introduction. As Bob said, my name is Justin Blumling. I'm a solutions architect with Panduit, and I'm going to handle the rack power portion of today's AI presentation. And we'll progress to my first slide. And I look at the AI revolution or situation that we have today through the same lens that I've really looked through the data center industry my whole career. And that lens is the same 3 variables of space, power, and cooling. And as time has progressed and the rate of change with hardware has happened, you know, we've thrown different designs and different considerations at that space, power, and cooling dynamic. In the mid-2000s, we had, of course, the big trends of virtualization, blades, and kind of the birth of high density. Once upon a time, everybody thought every rack would turn into a furnace with blade servers. I've certainly been in some hot aisles in my time that have both felt like a furnace and sound like an aircraft engine. So that certainly happened to some users. In the late 2000s, early 2010s, we kind of genesis of the sustainability movement, which dovetailed off of that kind of higher energy possibilities for data center hardware. And we also saw the birth of these giant cloud factories, those of AWS and Microsoft and others, and they became that term that we use so frequently today called hyperscale. And then in the late 2010s through now, we've seen aggressive AI developments, and aggressive may not be too strong of a term to describe what's happening today. And through that time, we've had to change our dialogue or our language about how we've talked about power within data centers. Before the birth of the high density / blade server context, we typically talked about power in data centers using a real estate term of watts per square foot. When density started to increase, we realized that that term was no longer significant or no longer accurate enough. So we started talking about kW per rack, and that was good to talk about the differences between a compute rack versus a network rack versus a storage rack, and allowed us to have granularity about where power is consumed across the data center. And we still use that metric today, but now as we're in this late 2010s, 2020, it becomes more apparent to talk about maybe kW per U or kW per chassis. We think about just the total sum of the rack without considering what the individual chassis or the individual use space might require. And that's especially relevant, for the cooling topic and conversation that we'll have later on in this presentation as well. If we think about some of the GPU generations that Bob talked about before, he gave kind of an overview of how Nvidia's generations have progressed over time. Here's a little bar chart with the kind of the polynomial graph, which shows what that trend line looks like is really, different and really outsized compared to what something as simple as Moore's law talked about, through even just yesteryear. So very pronounced improvement or increase, I should say, in GPU power. You can contrast that to the visual over here on the right, where who is a very well-known research organization, tries to illustrate or estimate what the typical rack densities are in some of the largest operators out there. So you can see they peg Meta between 12.5 to 15.8 kilowatts. They pegged AWS around 17. They peg Microsoft around 24. Of course, there are variations in ranges there. That's why you see the little, tilde as an approximation. But as Bob said, being that these guys are probably going to be the heavy adopters of the GPUs that are available by Nvidia and others, and looking at what these power profiles look like, there's ample opportunity for these power values to shift dynamically. And then it'll be interesting to see what kind of the cascading effect is on, others after these, right? What impact, because these are the early adopter guys that go all in. It'll be interesting to see how that cascades and trickles down to the other users who are out there in the data center space. So I'm going to take that same graph and contextualize it a little bit, and I'm going to use my trusty Panduit Flex Fusion cabinet here as the source of my bar graph. So on the x-axis here, I've got 3 generations of GPUs, Ampere, Hopper, and Grace Blackwell. And this is going to be my bar graph. And I take a look at what that looks like from a rack perspective, potential rack power, I should say, right? So if I outfitted a rack with the maximum possible servers that it could support in this generation, you can see 26 kilowatts, 40 kilowatts, and then 120 kilowatts. I kind of feel like I'm being misleading with this first entry at 26 kilowatts, only occupying maybe a quarter of the rack, because that is a pronounced improvement or uplift from where rack densities are today as an industry whole. As you can see here, using that same data from Omdia, this comes from their rack PDU report, where they take rack PDUs and they extrapolate, what is the average rack density, across the data center industry. They peg that as it should be 12 kilowatts into the current calendar year. And you can see we go from, doubling it to over tripling it to a kind of an order of magnitude difference, for what this particular platform looks like. So we're definitely talking about potential being the operative word, rack power that is beyond, what we're used to today as an industry level. If we were to take that 26 kilowatt example, right, move that over here and think, okay, what are the rack PDU possibilities that we could use to address a 26 kilowatt load? Some of the more popular varieties, at least in North America, are shown here. You've got, all of these are 3-phase, so you've got 208 volt 60 amp, which gets you about 17 kilowatts of power per PDU chassis. 8 kilowatts at 208/100, and you get 34 kilowatts at a 415 60 amp installation. So you've got those options available to you if this was the platform that you were to choose or the rack density. Certainly 26 kilowatt cabinets racks existed before AI. So there are operators out there who have practice in addressing, these types of loads. What's interesting though, is we talked about space, power, and cooling. On the topic of space, take a look at this particular plug type here. The image doesn't really do it justice. This is an example of what a 208 volt 100 amp plug could look like. And if we think about space, the height of this particular beast is 5.5 inches according to the spec sheet, and the depth of this housing is 12 inches. So again, the image here on the slide doesn't really do it justice, but when you're thinking about space, it's not just the macro level of space in the data center about how much square footage these pods and clusters would occupy, but how do I have a rack that's deep enough, to accommodate multiple of these circuits, and how do I sneak that through the top of the rack and connect it to either the busway above or a whip? The space considerations become very micro to the cabinet, and then put that in the context of other things that you may need, like Bob talked about, liquid cooling, manifolds, deeper servers. The space paradigm is going to become increasingly focused at the rack level. If we take a look at what another generation looks like, again, potential rack power, all of this information comes from the Nvidia reference architecture for this, the H100, excuse me. At maximum, you've got 4 of these chassis in a cabinet with a max power of 10 kilowatts. So kilowatts. Here at number 2, they've got 3 rack PDUs, which you can see here, which are pulled out, and you can see how they're designed to support the power supplies in any given chassis. These are 3 34 kilowatt PDUs. So these are 415 volt, 60 amp models in a horizontal form factor. And you can see that each one of them is designed to attach to a different C19 outlet, of course, for load balancing and other considerations. According to the specs, 4 of these power supplies have to be energized in order to support the unit's operation. So as you notice here, that's why they've got 3 PDUs here, because if I just had 1 PDU and I had 3 of these power supplies connected to this PDU and 3 connected to this PDU, if I lose one side, I don't have 4 power supplies available. I only have 3. So even though this is fed by a single source, UPSB in this example, you can see that it's divided amongst 3 PDUs to provide that support. So that really challenges the paradigm of kind of 2 PDUs per cabinet and maybe dual fed type of installation. So we have to think a little bit differently about how to power these, and then what the load balancing looks like from a 3-phase side to make sure that they're utilizing all of those phases efficiently and we don't have any stranded power. So the math becomes more complicated, to put it mildly, when we're thinking about this. So I'm going to wrap this all up, this quick summary, by saying this graphic here on the right is the common themes that we hear in the world of rack PDUs, regardless if it's an AI application or a traditional compute application. Of course, you've got power capacity, you've got outlet density, you've got the intelligence that you need at the PDU level for outlet energy measurements and other visibility. And then, of course, there's not a day that passes without hearing about some kind of cybersecurity incident where information is compromised. So obviously, having cybersecurity rooted at the PDU level, which is powering all of these servers that run, process other billions of dollars of transactions or hold other mission critical data, cybersecurity is important. And of course, given the rate of change and the rate of which these deployments are happening, the ability for a manufacturer to have speed to get product to market is absolutely essential. But in terms of AI, I think the most important bullet here is the top one, that your mileage may vary. Bob pointed out that we're talking in some cases about the full development deployment potential of what some of these power values are. But is everyone going to deploy 4 of those chassis per cabinet? No. Bob pointed out an example where someone may deploy 2 per chassis, or maybe you're a different enterprise where you don't need to build a large language model that's read every bit of code and every word of text that's ever been written. It's more tailored to what that business use case is. So don't be alarmed by the power forecast. Depending upon the nature of your business, your mileage may vary. I think we've articulated here that space, power, and cooling are definitely going to have a more micro focus, given all of the things that have to fit in the rack and attach to infrastructure above, manifolds, cable tray, busway. It can become very crowded up there. So we've got to think a little bit differently about how we do that. I think 415 volts will become increasingly necessary for new builds. We know that here in North America, 415 has a foothold amongst some of the hyperscale players and large data center operators, but there still are a lot of 208 volt data centers out there, especially those who aren't in kind of that type of operator space that we talked about. So as new facilities are investigated, 415 is a decision that merits investigation. And I'll wrap up my section here just talking a little bit about, from a product side, what Panduit has in the rack PDU space to try to address some of these applications. So if you think about high density PDUs like we talked about, we have a line within our umbrella catalog of PDUs that we call high density, which are 3-phase 30 amp at a minimum, so 8.6 kilowatts, going all the way up to 34.5 or 44.5 in a single chassis. Depending upon whether it's in North America or rest of the world, 42 or 48 outlet counts, right, to accommodate those high density deployments. And there's also the universal PDU, which leverages the same combination outlets that were shown on that high density PDU, where you have C13, 15, 19, 21 compatible outlets along the spank, and then you have the ability to mate a variety of different cords to that PDU depending upon your use case or depending upon where you're deploying PDUs globally. So if we think about growing into an installation, maybe we have 208 volt 60 amp to start, but we need to go to 415 volt 32 later on. The same chassis could accommodate those power capacities just with the simple swap of the universal cable here. So a lot of potential that the universal PDU will provide. I thank everybody for your time. Now I'm going to pass it over to Ann to talk a little about AI in the cooling world.
Good afternoon, everybody. Today, we're going to cover data center cooling. Thank you for the introduction, Justin. My name's Ann Kasarjian, Development Manager in the Data Center Practice here at Panduit. And data center cooling has been a hot topic for all of our customers that we've been engaged in. And I'm sure it's top of mind for you as well. Looking at the data center cooling market, the overall CAGR growth is at 15.63%. Now, looking at the different technologies and methods for data center cooling, you can see, in 2023, that in-row and in-rack cooling was at 58% market share. Followed by that is direct to chip at 29%. Followed by that is rear door heat exchanger. And then there's a little 6% of immersion. Now, if we fast forward to 2032, you're going to see a complete opposite of in-row and in-rack cooling methods versus direct to chip. So it's a complete flip from 58% compared to 57% come 2032. And the reason being is that AI is really taking a hold into all of our data centers, right, and into the environments, and the needs for cooling are dramatically increasing to help support all those applications. Now, there are challenges, and you might be faced with, some that are listed here. As we discussed, as rising rack power densities, it's really making traditional data centers cooling very challenging in all environments, including AI, including supercomputing. Now, you might ask, what are these industry-wide challenges? Well, there's insufficient cool air, insufficient airflow through the racks, equipment is failing, their system downtime, and this is key to take a look at. Manufacturers are not meeting the output size and the requirements as stated on their product specification sheets. And this is because every environment is different in terms of water pressure, water temperature, and we're going to share some tips today on how to exactly determine what that output requirement and that output is going to be in your environment. And lastly, as we know, energy costs are rising every day. Some of the strategies to look at when building your data center roadmap, as well as your cooling strategy. You would want to complete a thorough infrastructure assessment. Then you would like to complete a compatibility and integration analysis to fully understand what you have in your environment, what you'll have in your environment in terms of requirements and capacity, as well as what that integration is going to look like. Also, you'd want to take a look at your energy efficient analysis to fully understand how can I reduce my fixed costs with the different cooling methods associated when implementing these types of technologies in my environment. You would also want to take a look at your life cycle, where you are today, where you're headed, and what that roadmap looks like to provide the utmost output to keep your data centers cool, to support your AI environment, thus resulting in the utmost ROI that you're looking to achieve. And lastly, future-proofing your environment. You might understand where you are today, but it's very critical to take a look at your 3 to 5 year plan moving forward. And here at Panduit, we can definitely help your organization in terms of the roadmap planning of your infrastructure needs for now and in the future as well. This provides a topology and actually a landscape of understanding where the appropriate technologies are for your rack density levels. Now, historically, if you look at the 10 kilowatt on the bottom left, that's more of a legacy environment. But as we're moving up into AI, this is where you are exceeding 50 to 55 kilowatts. And that's where the active rear door heat exchanger would come into play, as well as the direct to chip to support your environment up to 200 plus kilowatts. These are the various data center cooling technologies in the marketplace. There are the universal aisle containment, hot and cold aisle attainment, air cooling, direct liquid cooling, air-assisted liquid cooling. And these are the pictures of those technologies associated. So to the left, you have your universal aisle containment, hot and cold. You have your in-row cooler, and that goes in the line of all your cabinets in row. Then to the right, you have the rear door heat exchanger that's built with a frame and back of each of your cabinets that provide the cooling method to your servers and everything that's located in the cabinet. Then you have your direct to chip. And that's what we talked about in the market analysis and the forecast where AI is leading the direct to chip initiative. And this type of cooling methodology and technology will cool each of your servers safely up to 200 kilowatts plus. And lastly, Bob previously talked about immersion cooling, and this is more along the lines of supercomputing, liquid cooling, for all your servers. We're not seeing much of that, primarily looking at AI today in the marketplace, where we are in 2024 going up to 2032. We're seeing a very high forecasted increase in rear door heat exchanger as well as direct to chip. This is just an example of the Nvidia L72 GB200 on what Bob discussed earlier. There's 18 servers, 36 Grace CPUs, 72 Blackwell GPUs, and this is all liquid cooled. The reason being is that it exceeds that threshold, and these have the capacity of 120 kilowatts per rack. And in addition to that, there are cooling pumps located on the bottom that you see to the right. The liquid cooling manifold connections are on the rack, and they face inward towards the servers. I want to thank you very much for your time, and I would like to pass it on to Bob.
Thanks, Ann. Now I'm going to wrap it up, and we're going to talk about what Panduit can do for you. Our goal is to be a trusted partner. If you succeed, we succeed, and that's what we've been trying to do for the past 50 years. So we have experts, we have R&D team, we have engineers and product managers, business development people. We've been doing a lot of the searching and researching, and we've learned so much about AI. Now we can sit down with you, we can help you so you don't have to go do this. And remember, we've always been that trusted partner. We have a whole ecosystem. We'll help you from every step, from initial development all the way into the final product. And that's what we want to be there, is your partner going forward. I'm sure you all probably all know this, but we'll just kind of wrap it up for, or talk about it for AI systems. We have a total infrastructure solution. You saw the power, you saw the fiber. We're going to be coming out with cooling systems. We've got the pathways. We've got all the other data center requirements. It's a total package. You won't need to go anywhere else. And while we're learning more and more about AI, and AI is quickly changing and will be changing with it, we're going to be bringing out more innovative products, more than the ones we've just talked about today. Again, we talked about it. We have the expertise. We'll give you the support. We're there for you. And how are we there for you? We've got a global partner program. We've got certified installers who've gone through in-depth training on all of our products. And what that does, that gives you a quality system when it's all said and done that you can rely on for your very critical AI data center products. And here's the global partner. We have distributors. We have system integrators. As you know, we have salespeople. We have warehouses. We have plants in every different region of the world there to help you out whenever you need us. And so we have three different sections of a data center, whether it be a traditional or, as we've been talking about, AI. You've got your gray space, and that is when the building goes up early. You're going to be putting in your power, you're going to be putting your cooling, and all of our electrical products like the VeriSafe or the cable cleats and the grounding and bonding and the safety systems are there to keep your employees safe, make sure that the system is smooth as possible, and make the production of this new building be ready for when you start rolling in all the electronics. First thing you're probably going to do is do the meet me room or entrance facility. On the left, you'll see our ODF. We just brought that out about 2 years ago. As you can see from that picture, it gives you really good cable management in a very easy, passive environment where you can make changes, you can move things around, and this is where you're feeding that outside pulling cable coming into your building and feeding it to the entire data hall. So this is a very critical portion of it, and our high-density ODF called FlexCore is as high density as you're going to find. It really gives you that cable management that a lot of people just absolutely have to have in these critical environments. We also have some high volume wall mount splice enclosures that go up to 6,912 fibers. You can see the dark OSP cables coming in, and then we switch them into the indoor fiber going out. We have all the fiber cabling and cable assemblies whether they be plug and play or spliced. And then what's really important is we're the leader in pathways, and that's the yellow fiber runner as well as wire basket. And when you're talking about AI systems, you're going to want to go to the maximum size pathways. You can go to a 24-inch fiber runner, and you can even go all the way up to maybe a 6 deep by 36 wide wire basket tray for maximum cable capacity. And then when you get into the data center itself, that's where the AI compute is. That's where all of our different fiber solutions, again, those high capacity pathways that protect your fiber and manage them. You have the PDUs that Justin talked about, and then obviously we have cabinets and the containment that Ann was talking about. Basically a total package. And how does that help you? All that plug and play fiber and all these systems that we can work out with the system integrators to give you something that rolls in, plugs in very quickly, that'll reduce your workload in the data center by 80%. We also have quick ship programs where our very most common products can ship within sometimes a matter of days to no more than a couple of weeks. We can't always guarantee this, but the products that we have, we stock at distributors and ourselves to make sure that we can always try to ship those very common products very quickly. And then reduce risk or circuit protection. Panduit always puts a lot of design into our products so that no matter what they do, they last a long time and they give you exactly what you need, a good long-term quality product. So when you bundle all that together, put in the support, I think you'll find Panduit is a great partner for you to work with on your AI journey. Thank you for your time. And now we're willing to take some questions.
So a couple of questions that came in that, Bob, I think you'd be great at answering. You mentioned that enterprise customers are likely to have 1 to 2 GPU servers per rack. Is that enough to have an AI system?
Absolutely. I think you heard Justin talk about it scales depending on what you need. A good example is this law firm I recently talked to. They aren't going to be using the internet for their training. They just have a lot of briefs, a lot of documents, and they're keeping it private. So they really only need around 4 cabinets, each with just 1 GPU server. By the way, that's a lot of compute power. And what that's going to do for them is they'll pull up all the briefs and you'll say, hey, based on this subject material, pull these briefs up and give me a synopsis of what it means. And in a matter of minutes, or maybe a few hours at the very most, what used to take weeks of having law assistants pull all this data up is going to pop up and it'll be summarized for you. And you can do that with 4 or maybe even less AI servers. So as Justin said, you don't need to have massive clusters. Maybe just a few work. So absolutely, enterprise applications, they don't have the power to fully load 4 or so servers per rack. They'll probably put 1 in, and if they need multiple racks, they may have those racks situated in different areas, not next to each other, so that they can keep their cooling and not have a hotspot in their data center environment.
Great, thank you. Here's another one. How are AI clusters connected to the internet?
Right, I didn't really go into a lot of detail, so that's a good question. Everybody has their network system now. If you deal with a hyperscaler, they've got their normal network. That is the front end. The back end is the AI network. And so as we talked about in the networking segment, you have the compute going up to lease, going up to spines, and that is your back end system. Now, when the spines of the back end systems talk to the spines in the front end system, that's when you can be switching from InfiniBand to Ethernet, but that's how you lay out your whole total architecture. So you use your existing network that runs all the networking that you're doing today out to the internet, and then you just tag into that AI system in the back end, and you make sure you design that for seamless applications.
Perfect, thank you. Last one here. So with the high number of fibers used with AI, do you need any specialized pathways?
No, as I talked about it just a few minutes ago, the fiber runner and the wire basket that we talked about, that should meet all your needs. We have seen several of the really large customers going with multi-tiers, so they'll have maybe a tier of wire basket and then a couple tiers of fiber runner or vice versa. That helps you really have a lot of capacity, but you probably will be sticking with a 24-inch wide fiber runner and a 24-inch wide wire basket. We are also offering upwards of 36 inches, but you're not going to be at the 12 and 16 wide pathways like most people are today.
Sounds good. Thank you, Bob. Appreciate it. So Justin, I think we got a couple questions in that are within your wheelhouse here. So which variety of PDUs do you think will be the most necessary to handle AI-powered densities?
If I had to guess, reading the tea leaves or the magic 8-ball or whatever you want to call it, I would say that the 415 volt 60 amp variety will probably come out in the lead, just due to the fact that that is in the Nvidia reference architecture. So that to me seems a good one, a good guess for the one that will have pole position. We're still seeing in North America, a lot of facilities, right, because of the way we do power in North America, that we have 208 volts and they are locked into that 208 volt architecture, and they can't get to 415 without a very, very invasive, exhaustive project that may not be suitable for an operational data center. So you will see, a need for 208 volt, 100 amp as well, which will give you that 28 kilowatts of capacity. And then there's even talk about, exploring higher voltages. 480 volt is a predominant distribution strategy here in North America, commonly set to 415 or 208. But will we see more deployments that will accommodate that? If I were a betting man, I'd say yes, but I think it's probably too early to tell.
Great, thank you. And one more here. How could a 120 kilowatt rack be powered?
Yeah, that goes back to the kind of the last one, right? If we look at the example that Ann and Bob had in their slides, right, that was the 120 kilowatt liquid cooled rack. That was actually, if you look at some of the pictures that are available online, that is actually done in an OCP style cabinet with a direct current bus bar. So they bring power shelves into the rack, they bring high voltage AC into the rack, and then that converts, there's hardware in the rack that'll convert that to DC and then supply power to a bus bar in the rear of the cabinet. So that's how that particular design has been proposed. Of course, that's a really progressive way of doing it. It'll be interesting to see if that if that takes hold in the market, and that's an architecture that a lot of people will choose to deploy.
Good deal. Thank you. Appreciate it. Hey, Ann, we've got a few questions that you could answer for us here. So what are the best 5 practices for optimizing data center cooling?
That's a great question. Thank you so much for asking. I would say the first one is it is a necessity to create technical capacity. And the reason being is that any plan for a data center must account for how much data can be warehoused and processed. Moreover, you want to be sure to account for possible future growth. Even if you don't initially invest in all the hardware that you will eventually need, your plan must allow for growth without making that awkward layout, because it makes things very cramped or messy. Secondly, you must account for thermal needs. This is very critical because all of your data center facilities are going to generate tremendous amount of heat, which requires successful pre-planning and resources to dissipate that. Cooling malfunctions happen all the time, and this is because of improper computations that can cause components to quickly overheat and destroy sensitive electronics that you have in your data center. Popular, I would say, layout solutions include hot and cold aisle layouts that we discussed earlier, as well as rear door heat exchanger, direct to chip liquid cooling techniques These are the best possible airflow to pull away from the network equipment. Thirdly, I would say apply the most efficient power consumption in the environment by doing all of the assessments and, in analysis that we talked about earlier today. And you definitely want to collaborate with a trusted manufacturer, a trusted partner, and the fifth would be collaborate with Panduit for this.
Great, thank you. That's a lot of good information there. Another one that's here is what cooling method are AI data centers using today and in the future?
Another great question. It's a combination of air and liquid cooling. And we talked about this in the presentation earlier, where AI is heading today and in the future is, the techniques and technologies on what we're seeing in the marketplace. Definitely a rear door heat exchanger behind every cabinet, as well as direct to chip, and also CDU manifolds that will be added onto the environment. We're seeing that all day and all night in AI environments and supercomputing environments as well.
Great, thank you. So what are 5 tips for future-proofing your data center?
5 tips, that's a great question. I would say the first tip that I would give out is installing more cabinets and infrastructure within your environment. Let it be brownfield, let it be greenfield to help support the growth. I would say work with our Panduit team, most definitely, to acquire the proper racks and cabinets and power that's needed for your environment. I would say managing and monitoring your environment to see what's actually happening today and what changes and alterations need to be made as your cup grow in terms of kilowatts. And lastly, work with a cooling expert, with a trusted manufacturer, work with Panduit. So that's what I would like to say.